Hello students, I am Dr. Ravindranath Rajotia and I am taking a course on circuits and systems. Today we'll see part 3 of the type of the signals. In the previous lecture, we studied about the even and odd signals, odd part of a signal, and said that a signal xt can be represented as sum of two signals which are the even part of the signal and the odd part of the signal. And we know that what even part is and what odd part is, that we discussed in the previous lecture. Today we want to see that given a signal, can you identify whether the signal is odd and or even? Let's take an example to find if a signal is odd or even. For example, example number 1, if I say you are given f of a x is equal to 3x square plus 4. Find whether this signal is even or odd. Find if this signal is even or odd. We know from our previous discussion that for a signal to be even, it has to satisfy the condition as f of minus x is equal to f of x. And for it to be odd, the signal f of minus x will be equal to minus f of x. Let us see by putting x is equal to minus x in the above signal and find what the outcome is. So if you put x is equal to this x as a minus x into the right hand side of the equation or the signal, so you will get for x we will write minus x square and plus 4, which is nothing but the same, that is 3x square plus 4. So what do you observe here, that the outcome, that is f of minus x, is same as what it was f of x. So therefore you can conclude that your signal fx, which was nothing but 3x square plus 4, is an even signal. Let's take one more example. Suppose suppose you are given a signal f of x is equal to 7x of cube minus 3 of x. Now let's find out by putting x is equal to minus x. So the solution is putting x is equal to minus x. What do you get is 7 minus x cube minus 3 minus x, which is nothing but minus 7x cube plus 3x, which is nothing but minus, if I take common outside, so inside will be 7x cube, the minus is taken out, minus 3 of x, which is nothing but equal to minus of f of x. So therefore, what do you see? That f of minus x is equal to minus of f of x. So therefore, this signal is odd. Therefore, 7x cube minus 3x is an odd signal. So I hope this clarifies what exactly an odd signal and even signal is. Now, let's take up another type of signal. The last in this last type of the signal, let me write here as the signal can be a periodic or non-periodic. So what exactly a periodic signal is? If a given signal, if a given signal repeats after a fixed time period t, where t is a positive integer, non-zero integer, such that for it to be periodic, it has to satisfy x of t plus t is equal to x of t. This means, for example, you have a signal as this of time period width t, then if the signal repeats after the t, so let's say it repeats and goes on, then we will say that this particular signal is a continuous periodic signal. So here this t is a positive non-zero value. Whereas if the signal does not satisfy this condition, then we will say the signal is a non-periodic. For example, for a signal to be non-periodic or also called as aperiodic, in that case, it will not satisfy the condition. That means this will be not satisfied. Then we say that signal is a non-periodic signal. Examples of non-periodic signals can be, let's say you have a pulse of this type. This is a non-periodic pulse. Whereas the waveform such as the sine waveform is a periodic waveform. Now in general, we can also write as x of t plus mt, where m is the integer values is equal to x of t. For example, to find out whether the signal is periodic or non-periodic, let's take up some examples. Let's take some examples. For example, check if the question is check if the signal cos of 0.01 into pi and n. Remember, for the if the signal is not a continuous but a discrete, see what the difference will be. Only difference, if it is periodic, it has to repeat the pattern. So in the discrete time domain, you will have x of n plus mn is equal to x of n. That means if you have a sequence, the sequence So if you have a sequence, what do you see? That this sequence repeats. And if you say how many samples are there, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So after 11, these samples, here the value of n is equal to 11. So if you count them as 1, 2, 3, etc., here it is the 11. So in that case, you say n is equal to 11. So after 11, after every 11 or some multiples of 11, the waveform repeats. So hence we'll call this as a discrete time but repetitive sequence. Let's check whether this particular sequence is this, and what type of this signal will be. This will be discrete signal. Let's check out. We know that the solution is we know that I can compare this signal as cos of 0.01 pi n. Let us compare it with the cos of omega n. So this means the omega n part should be equal to this part. So let me write this, that omega n is equal to 0.01 into pi of n. N gets cancelled. So omega is 2 pi f is equal to 0.01 pi. Pi gets cancelled. So get f is equal to 0.01 divided by 2 is equal to 1 by 200. And this is of the form of k by, let's say, some number m. For this signal, for the given signal to be periodic, so you can mention, you can just have a note of it. For a signal, to be periodic, both k as well as m should be the integers. So here I find that my k is equal to 1. So here k is equal to 1 and m is equal to 200. So therefore I can say that the signal is a periodic one. Signal is periodic. Now if you say, and what will be the period after which it repeats? If you want to find out the period, I know f is equal to 1 by 200. So what will be the t? T will be the reverse of this. So t is equal to f is equal to 1 by t. So t will be 200. So t will be 200 in that case, because I know that f is equal to 1 by t. So after 200 samples, this particular pulse will repeat. So I guess the concept of a periodic and a non-periodic signal is, if you want to take up another example of to find out whether this, let me take one more example so that the concept is again very well clear to you. Let me just erase from here. And let me take one more example. And in this case, now the example I take is, suppose I take the example as question number 2. And for this, let's assume that I have a signal as sine of pi plus 0.2 n. Let's say now in this case, I have this particular signal. So what exactly we mean here? I mean here that the signal is of the form omega n plus some phi. So this is a phase shift. So I can write this as sine of the internal part. This is of the form as sine of pi plus 0.2 n. I can write this as sine of omega t plus phi, some phi value. And this phi is a phase shift. This is nothing but a phase shift. This is nothing but a phase shift. So with this, now what you are left with is I have the value as 0.2 n is equal to omega t. Let me write this. Omega t is equal to 0.2 n. Omega t, since it is a n, so I can write here as a omega n. So omega n. So n gets cancelled. So I'll get 2 pi f is equal to 0.2, or f is equal to 0.2 divided by 2 pi, which is of the form k by m. And for the signal to be periodic, I know the condition. What the condition is? Both the k and m should be integers. So for it to be periodic, I know that k and m, that is both must be integers, but it is not the case here. But since m is not an integer, because it is equal to 2 pi, because it is equal to 2 pi. It is not an integer. So therefore you conclude that this particular signal sine of pi plus 2 n is not, therefore you conclude that sine of pi plus 0.2 n is not a periodic signal, So I think this gives a very clear thought about that given a particular signal, how will you find out whether the signal is the periodic or non-periodic. So with this, we conclude the topic on the different types of the signals. So wherein we had studied different types of the signals as the continuous versus the discrete signal. Then we studied analog versus the digital signals. Then we studied the real valued signal versus the complex valued signals. Then we studied the deterministic or random signals. Then we said that signals can be even or the odd signals. And then we studied the signal is a periodic or aperiodic signal. So see you in the next lecture. Thank you for watching it.